In Lesson 4, everything starts to come together. Our launch, explore, discuss. Scott has decided to add push-ups to his daily exercise routine. He keeps track of the number of push-ups he completes each day in the given bar graph, with day 1 showing he completed 3 push-ups. After 4 days, Scott is certain he can continue this pattern of increasing the number of push-ups he completes each day. Now, we don't necessarily want to do problems 1, 2, and 3 in order. What we want to do is we want to first analyze the pattern. The best way to do that is to, first of all, let's do some counting. So on day 1, there was 3. On day 2, there's 5. On day 3, there's 7. On day 4, there's 9. How are we moving from one number to the next? We are adding 2. And since we are adding 2 every time, that tells us what kind of a sequence we have. This is an arithmetic sequence. That's what question number 3 is asking. What type of sequence? It's arithmetic. How do I know? Because we are adding 2 each time. This number 2 is called the common difference. We'll look at that in our wrap-up section. Now, from this, let's construct a table and see if we can come up with an explicit equation. Oh, by the way, we can come up with the recursive equation now, because the next is just the previous plus 2. That's listed here. Next equals previous plus 2. In our table, we have the days and we have the push-ups. On day 1, he does 3. On day 2, he does 5. On day 3, he does 7. On day 4, he does 9. If we project ahead one more day, that would be 11. So how do we get the numbers from 5, 7, 9, 11, etc.? Well, obviously, we're starting with 3, and then we add 2. And then we add 2 again. And then we add 2 again. So what you'll start to notice is the connection between the number of 2's we add and the day. And that connection is, let's use one of these as an example. On day 4, we added 2 3 times. So the day is trailing, or you could say if you take 1 away from the day, you will have the number of 2's. So now we're ready to generalize to our explicit. And that would be D for day, day sub n, or day of n equals start at 3 and add a number of 2's. How many 2's? 1 less than the day. Now we can look at question number 1. How many push-ups would he be able to do on day 10? So on day 10, we started with 3 on day 1. We added 2 10 minus 1 times. That's 3 plus 2 times 9, or in other words, 21 push-ups by day 10. Number 2, let's finish that up. We have a table. Let's look at the graph. So remember, we can use any part of this graph we want to we're in charge here. I'm just going to go from here. And I just want to get a peek at what's going on. So if I go 0, 1, 2, 3, 4, etc., and then I'll use these 1 to 1. I'll go 1, 2, 3, 4, 5. I'll label the fifth. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 at the top. So here's my dots. Let's do those in green. I've got day 1 is 3. Day 2 is 5. Day 3 is 7. Day 4 is 9. And let's do one more day here. Day 5 is, oops, I got that dot in the wrong spot, don't I? Day 4, there we go, at 9. And day 5 at 11. Now, what you should notice here is that the dots go in the pattern of a straight line. That's always going to happen for an arithmetic sequence. In addition, we're thinking back to 7th grade when we were looking at slope for the first time. The slope of going up and going over, we're going up 2 units, we're going over 1 unit. That's a slope of 2 over 1, or 2. And that is our common difference. That's how much we're changing every time. So let's sort of wrap this up here in our takeaways. So for the table we were able to identify this common difference. And because there was a common difference, that's how we know it's an arithmetic sequence. Now, for the explicit equation, I'm going to give you a little bit of a hint here how to do this in the future. For your total of n, you're going to make it the first number plus the common difference, point to it, times n minus 1. And that will be true when we start at 1. When starting at n equals 1. The recursive is going to be next equals previous plus that common difference again. And the graph will be linear when you have an arithmetic sequence. Those are our big takeaways from this lesson. Now, independent variable, dependent variable, you probably should have heard of this in junior high. Independent variable refers to the x variable, dependent variable refers to the y. And let's just look at our retrieval on this one. We used the explicit function to come up with the function values. F of 2 would have been 6 times 2 plus 5. That's 12 plus 5, or 17. F of negative 2 is 6 times negative 2 plus 5. That's negative 12 plus 5. That's negative 7. We have g of x is 3 to the x. G of 4 is 3 to the 4th power. That's 3 times 3 times 3 times 3. That's 81. G of 0 is 3 to the 0. Taking a number to the 0 power is actually equal to 1. And finally, let's look at this graph. For problems 3 through 5, use the graph to answer the questions. Question about a biker over time and the distance that was traveled. How far away are they at 0.5 hours? Read 0.5 on the graph right here. Go straight up and get your answer as, look straight over, 8 miles. How long does it take them to reach 2 miles away? Go to 2 miles here on the graph, go straight over, then go down, and that's somewhere around, let's say 0.25. About 0.25 hours or a quarter of an hour, 15 minutes. Which of the variables is represented by f of n? F of n is this vertical. That's the distance. Distance is f of n. Okay, and then we looked at these real quick. If you want to find the slope in this form of an equation, it's the number in front of x. It is 8. And for finding a slope from 2 points, it's the change in the y divided by the change in the x. There is a formula for this, but basically all you've got to do is subtract. Subtraction finds change. So you go 5 minus negative 11 divided by negative 2 minus 6. Oops, let's do that right. So the slope is 16 over negative 8 or negative 2. That's supposed to be a review again from 7th grade. So we'll be using that in the near future. See you next time.